we're ready to start with our second part of graphing trig functions. It gets a little more interesting today. We're going to do what's called phase shift and vertical shift, but you've done most of this many times before because it's nothing more than shifting a graph horizontally and shifting a graph vertically. So I want to take you back to those parabolas we all know and love so well. If you have the regular equation x squared, we know it's a parabola that is centered with its vertex at the origin. But if I have you do the parabola x plus 3 quantity squared minus 5 and say, where does that shift to? I hope you're all going to tell me, well, it's going to go left 3 and down 5. Well, shifting trig functions is exactly the same way, but except since we are graphing using radians, our horizontal shifts are going to be in terms of pi. We're going to shift right and left some amount of pi units. So this example I have here with a sign of the quantity x minus pi over 4 plus 1, I just for right now want to know where is it going to shift. And hopefully you're going to say, well, if it's x minus pi over 4, then that means it's got to go right pi over 4. And the plus 1 is just like when it's a number outside, we go with the same direction as the sign, so it's going to go up 1. Okay, what that's going to do is that's going to change our starting point, just like it's changed the starting point of every graph we've ever drawn. Instead of your point starting at 0, where you got lucky enough to have this last assignment start, in this case, your 5 points that you plot would start at pi over 4. So nothing's going to change there. It's similar to what you already know. It's just a little bit of different weird units because you have to deal with the radians as your x-coordinates. Okay, so we're going to try one here. I have an equation up here, y equals 3 cosine of the quantity 4x plus pi minus 2. So now there's going to be 4 parts you have to find out before you can start drawing any trig graph. You need to find the amplitude, which, if you recall from the other day, amplitude is the height of the wave off the axis. The period, how long the wave takes to do one cycle. And then, of course, vertical shift and phase shift. So if I was to ask you to look at this cosine problem and name you the amplitude, hopefully you would say, oh, well, the amplitude is a nice round 3, the number in front of cosine. The period, you'll recall, we found by doing 2 pi divided by b, b being the number in front of x. So in this case, the number in front of x, the coefficient, is a 4. So now our period is pi over 2. If I asked you to find the vertical shift, the up and down shift, and there's a reason I have you doing this one first, we would say, well, it went down 2, so it's shifting down to negative 2. And then lastly, this is the tricky one. They call it phase shift because you're shifting the phase of the wave. You're making the wave start at a different location. It's the same thing as horizontal shift, but we call it phase shift. Okay, the trick here is the fact that I have a 4x plus pi up there. I can't tell which way it's going to shift as long as that 4 is in front of the x. Our normal shifting requires it to be x plus or minus a number. Okay, there's 2 ways you can solve this. You can either factor a 4 out, which would make that become x plus pi over 4, in which case that means we went left pi over 4. Or what most students prefer, if you just simply take that quantity, set it equal to 0, and solve it, you're going to subtract pi, divide by 4, and so it's going to shift and start at negative pi over 4. Most people prefer that method. It seems more logical to just solve the thing and find out exactly where it's going to start. Okay, I want to turn this information into a general set of formulas, though. So I want you to look up here at this equation I have, and notice I have a blank. If that blank line was filled with sine or cosine, we're going to fill in these 4 values. So if it was filled with sine or cosine, we would say the amplitude is just A. And if you recall, it's always got to be positive, so we absolute valued it. The period, we just did here a moment ago, had to be 2 pi divided by b. And once again, it's also got to be positive. Okay, the vertical shift, which letter up there tells us which way it's going to shift? Well, of course, it's the number added and subtracted, so that would be C. And then, last but not least, we would have the phase shift, which would be the one that's tricky. How do I come up with the formula for phase shift? Well, since that's bx plus d, I think the easy way is to set it equal to 0. And if I solve it, I'm going to end up with a negative d over b, which means I've shifted it to, in this case, left d over b, whatever those numbers might happen to be. So you can also memorize this as a formula as simply negative d over b. Okay, so let's actually try drawing a graph with some actual numbers. I've got a graph down here at the bottom where we have y equals a negative 4 sine of 2x minus pi plus 1. Okay. Every single time, first thing you've got to do is identify those 4 parts of the graph. So you're going to have to go, what's the amplitude? Well, amplitude's got to be a positive number, so we would say the amplitude is 4. But in reality, there is a negative on it, which we know causes what to happen to the graph? Well, yeah, the graph's going to go down first, so I need to do a 4. I put a negative behind it in parentheses to remind myself when I actually start to plot the points, I have to go down first. The amplitude is technically 4, but that negative is important to our graph. Okay, then I'm going to ask for the period, where you're going to go 2 pi divided by b. In this case, b is 2. So now your period is down to a length of pi. So that's how long it's going to take pi units to do one wave. Okay, and now the new stuff, I need to do a I personally always do the vertical shift first. Vertical shift up or down is 1. And then the real key, we need to do phase shift, which, if I do phase shift, I have to set that quantity equal to 0, in which case x is going to equal, I'm going to add pi over and divide by 2. So I'm going to shift and start this graph at positive pi over 2. Okay. Those are the 4 components I need. I recommend, because I personally forget this all the time, I go mark off the vertical shift and the amplitude just absolutely as soon as I have it figured out. So if the vertical shift is 1, I'm going to go up 1 unit to plot this thing. And remember, we're counting 2 boxes when we count a unit, so I'm going up 1, and I'm sitting on the x-axis. I also notice, though, that I have an amplitude of 4, so that means off this new vertical shift here, that's my new x-axis, when you count the amplitude, you count it off that vertical shift. So I actually have to go up 4 units off that shift, 1, 2, 3, 4, and down 4 units, 1, 2, 3, 4. So I know that's how high and low I'll have to go when I put my wave on here. Alright, here comes the tricky part. This is the part that if we're going to have issues, it's always right here. You have to find those 5 points to plot. You have to know which 5 points on the x-axis you're going to use in order to mark off your wave. Okay, before, you took the period times 1/4, so you could figure out how far apart they're spaced. You're still going to do that. So in this case, our period is pi. If I times it by 1/4, I'll have pi over 4. But last time on your assignment, you always do, you started at 0, and then you added 1/4, and you kept adding a 4th on, which would be 2/4, 3/4, etc. But in this case, that's not what we're doing. In this case, we have to start at where it horizontally shifted to. So you have to start at the phase shift. So I need to erase this. And I have to start at pi over 2 since that's where the phase shift is. So that is really crucial that you start at the phase shift. Now, how do I figure out where the next point's going to be? Well, it's got to be over that 1/4 of pi, because they're spaced pi over 4 units apart. And here's where it gets tricky. You have to actually add fractions. I know it's difficult, but I'm confident we can master it. So how do I add 1/2 plus 1/4? Ignore the pi's, just add the fraction. What's a half plus a fourth? Well, hopefully you're going, oh, 2/4 plus 1/4, that would be 3/4. And then I recommend you just keep adding. What's an add another fourth? 4/4. And then 5/4 and 6/4. After you get those figured out, then yes, some of those reduce. Fine, go back and reduce them if you want to, but just space them out evenly by fourths. So I would want to go to my graph paper, and I would want to mark off those 5 points, because I want to make sure I've got them evenly spaced and I haven't goofed up my simple arithmetic. So if I find pi over 2, there's the first point. That color's not going to work real great. Let's try a different one. Something dark. Okay, so here's pi over 2. Then I had 3/4. 4/4 is really just pi. 5/4, 6/4 reduces to 3/2. And there's my 5 points where I'm evenly spaced. If, as you discovered on your assignment, if you have numbers that don't fit, just renumber these numbers on your graph paper, change them to whatever numbers you need, just evenly space them is all that matters. Okay, so now that I have those 5 points, now I can actually plot sine. And so you have to ask yourself 2 questions. Where does sine start? Does it start on the axis or at the peak? And hopefully you're going, yep, sine starts on the axis. But remember, our axis actually moved up 1 unit. So when I go to plot this on the axis at pi over 2 over, pi over 2 is my start point, I should be on the axis. But now, here's where the amplitude, all that stuff comes in. And remember, my amplitude was a -4, that number. So instead of going up first with my sine, I'm going to come down first. I've already marked off how low I have to go to be 4 down. So at the second point over, 3 pi over 4, I'm coming down 4 units, and I'm down here at the bottom of my wave. Okay, at pi, I will be back on the axis. The next point over, 5 pi over 4, I would be going up then, so I would be at the highest point, clear up here at a peak. Then, at 3 pi over 2, I am back on the axis. Once you have your 5 points, then yes, you can do just like you did on your last assignment, drawing your wave. Try to round those curves. Whoops, I kind of missed that last curve a bit. Try again on that one. Try to round those curves a little bit more. And you've graphed your first sine with phase shift. Now, the key to the whole thing is finding those 5 points. Remember, you start at the phase shift, and you add 1/4 of the period on each time. If you really have a difficulty adding fractions, heaven forbid, you do have a calculator. But that is the biggest issue, is finding those 5 points. Okay, we're going to pause here, and then we're going to do another one.